So the first question is, how much positive and negative charge is there in a cup of water? And let we assume that the cup contains 250 cc of water. The quantity of water is 250 cc. You know, 1 cc is 1 cc of water equivalent to the 1 gram. And what about 250 cc of water? Mean 250 gram. So we are having 250 gram of water in that cup. Now coming, what is the molecular weight of water? It is H2O. Molecular weight of water is H2 mean, that is 2 plus oxygen mean 16. It is 18. So if I took 18 gram of water, then it will contain how many molecules? I mean, whatever the molecular weight, 13 gram, it must have then molecules, number of molecules equals to Avogadro number, 6.023, 6.023 into 10 raised to power 23, the number of molecules in 18 gram. And what about the number of molecules in 250 gram? So in 250 gram, the number of molecules 6.023, 10 raised to power 23 divided by 18 multiplied by 250. So this is a number of molecules. Now we need the charge. The question is, what is the charge in that cup? Maybe negative charge or maybe positive. Okay. Now one H2 molecule contains how many electrons? H contains 1 electron, second H contains 1 electron, oxygen contains 8 electrons. The number of electrons equals to 10. So in one molecule there are 10 electrons, and you are having so many molecules in one cup of water which contains 250 cc water. Okay, then how many electrons in that cup? Multiplied by, because this is one molecule, number of molecules in 250 gram. So what are the total number of electrons then? Multiplied by 10, because each molecule having 10 electrons. Now it comes the total electrons. Now we need the charge. Very simple. 1 electron having charge 1.6, 10 raised to power minus 19 coulomb. And you are having so many electrons. So that means this multiplied by 1.6 into 10 raised to power minus 19, it comes it will be the answer in coulomb. So you find this answer, it will be 1.338 into 10 raised to power 7 coulomb. So this is the charge that cup will contain. Okay, and this charge is of course a negative charge. So you think a problem, what about the positive charge? How much it is there in that cup which is having 250 cc water? And if you found, then write me in the description box. Okay. Now second problem. if a body gives out 10 raised to the power 9 electrons every second, how much time is required to get a total charge of 1 coulomb from it? 10 raised to the power 9 electrons every second. So how much charge every second? 1 electron having charge 1.6 10 raised to the power minus 19 coulomb. This is a charge with 1 electron. And because they are the 10 raised to the power 9 electrons, so charge per second, in every second, the body giving out how much charge? 1.6 10 raised to the power minus 19 multiplied by 10 raised to the power 9. It is in coulomb. So 1.6 into 10 raised to the power minus 10 coulomb. So in every second, the body giving this much charge. In every second. 1.6 into 10 raised to the power minus 10 coulomb. The time is 1 second. And for 1 coulomb, the time required is 1 upon 1.6 into 10 raised to the power minus 10 seconds. So that is 10 raised to the power 10 upon 1.6 seconds. So it is, the answer is 6.25 into 10 raised to the power 9 seconds. So this is the time required for giving a charge of 1 coulomb if it is giving 10 raised to the power 9 electrons per second. Okay. Next question. This is a line. Okay. Here is the charge. Here is a charge plus Q and plus Q. The question is, at the midpoint, we have to put a charge. It is not given its magnitude, not given its sign. It is the question. What about this unknown charge if we place it here at the midpoint of the line, so that the whole system, it comes in equilibrium? This is the question. Think over it. Now look. This is a positive charge, positive charge. Now because it is not given what about the sign and magnitude, but whatever it is, let it is positive. And if I place it, if it is placed here at the midway, then this charge will repel it along this side. This charge will repel it along this side. And repulsion will be the same in magnitude, because the charges they are in magnitude, they are same, and distance, it is also the same. So repulsion will be equal. So net force on this charge will be 0 if it is positive. Now if it is negative, then this charge will attract minus Q along this side. This charge will attract minus Q along this side. Again the two attractions, they will be equal, and the net force on this charge will be 0. So this charge may be positive, may be negative. It is net force on it is 0. It does not depend upon the sign. But what about the net force on this charge and net force on this charge? The total system will be in equilibrium if net force on this charge is 0 net force on this charge is 0. Okay, if it is positive, suppose this charge will repel plus q along this side, right? And this plus q charge will also repel to plus q along this side. So the total force will not be 0. Now, if this charge is negative, then this charge plus q will repel it along this side, and minus q will attract it along this side. And if its magnitude is such, the two forces may comes equal and net force becomes 0. Again, if it is negative, what about the net force here? This is plus q, it will repel it along this side. This is minus q, it will attract it along this side. If its magnitude is such that the two forces are equal in magnitude, the net force on this charge also becomes 0. So with minus q, the whole system comes in equilibrium. Okay, net force on this will be 0, on this will be 0, on this will be 0. But if it is of positive sign, then net force on this charge will be 0, but not on this charge and not on this charge. So one thing is clear. If this charge is positive, this charge is positive, then this charge, should be with opposite sign of the two. Okay. Now, because on the net force on this charge is 0, maybe it is positive or negative, no problem. Let's concentrate on the charge which is at E. The force on A, because of this charge, capital Q, it will be along this side. So FEB, it is constant Q into Q upon total distance is 2A whole square. Now there is another force on this charge because of this one, and because it is unknown whether it is positive or negative. Okay, but the force will be there now, and this distance will be the half of this distance is small a, and the force of this charge on this charge, it is the constant capital Q small q upon A whole square. And sum of the two forces should be 0 so as to have the equilibrium position, so that the force at E becomes 0. So it is constant Q square upon 4A square is equals to minus constant capital Q small q upon A square. Okay, that means so the answer of Q becomes minus Q by 4. The whole system will be in equilibrium if this charge, it is the opposite in sign of the two. Opposite in sign of the two mean minus Q by 4, and in magnitude 1/4 of this charge or this charge. Then on this charge the force will be 0. At here it will be 0. At here it will be 0. It's a very important question. The whole system comes in equilibrium if this charge is negative and 1/4 in magnitude of this charge and this charge. Okay, that's all.